Hello everyone, this is our first model problem on analysis. We want to know if this heat exchanger network is working with minimum heating and cooling. For that, we're gonna calculate and draw the composite curve diagram and see what is the minimum consumption. See the process. We have just one cold stream, number 3, from 35 to 130 Celsius, and two hot streams, number 1 from 210 to 45 Celsius, and number 2 from 120 to 40 Celsius. Concerning enthalpy flows, we can split streams in chunks, or we can do as long as we can every stream. But for that we must check that the MCP, the thermal inertia of every chunk, is similar. Here you can see the streams by chunks, by sections. Stream number 1, the hot one, in 2 chunks, stream number 2 in 2 chunks, and stream number 3 in 3 sections. Then you can check that the MCP of both chunks in stream 1 is similar. Same thing for stream number 2, and also very similar in stream number 3. So we can take the whole streams as linear, and using just the stream temperatures and the summation of every heat exchanger enthalpy flows. Concerning the minimum temperature approach, we have 20 degrees in both process heat exchanger. In heat exchanger number 2, this from 55 to 35, 20 Celsius, and in heat exchanger number 1, from 65.5 to 45.5, 20 Celsius. So the minimum temperature approach we're going to use is 20 Celsius. And about the current utility use, for heating we have just one heater, H1, that is 697 kilowatts, and for cooling we have two coolers, cooler 1 and cooler 2, and the summation of both is 162 kilowatts. So we can calculate and draw the composite curve and calculate the minimum heating and cooling and compare with the current use. The cold composite is very simple because it has just one stream. It coincides with stream number 3, and the hot composite got 2 streams that must be compound, but it's not complicated, taking the temperature limits of the intervals and summing up the contribution of enthalpy flow at each interval, we get the composite curve. And when we place it at 20 Celsius, exactly like that, we can get the minimum cooling, that is 101.64, and the minimum heating, that is 636.64. Comparing with the current use of utilities, we can see that we are using in excess 60.36 kilowatt of heating and of cooling. Remember that this must be the same. That means a 9.5% excess of heating over the minimum and a 59.4% of cooling. You can use also the web application to calculate and draw these composite curves.